Hello, dear candidates. Welcome to the GCE Maths panel. And in this particular presentation, we are looking at June 2021 A-Level Maths Paper 2. June 2021 A-Level Maths Paper 2, 770 and 765. So it will be very important that you watch this paper to the end and you don't forget to subscribe. You can visit www.gcemathpanel.blogspot.com where you can get all our past papers and correction. www.gcemathpanel.blogspot.com where you can get all our past papers. And please do not forget to subscribe, because when we upload new videos, you'll be immediately notified. So let us begin this paper of June 2021, paper 2, 770 and 765. Don't forget to share this video with your friends and to leave your comments. Without subscribing, you cannot watch paper 3. So the first question reads, a polynomial function f of x is defined by f of x equals 3 minus ax plus bx squared minus x cubed. When f of x is divided by x plus 2, the remainder is 45. Given that 3 minus x is a factor of f of x, find the values of the real constants a and b. So with this question, we have to apply the knowledge of the factor and remainder theorems. And we know that x plus 2 is not a factor. That is why the remainder is 45. On the other hand, 3 minus x is a factor, which means the remainder is 0. So we can form two equations with two unknowns a and b, and we solve that simultaneous equation. Let us answer the first part of question 1, and then we move to the partial fractions. So we have been told this equation on the bottom right. So when we divide this by x plus 2, the remainder is 45, right? So we equate x plus 2 to 0. That will give us x to be equal to -2. And since x plus 2 is a remainder of 45, it means f of -2 will be equal to 45. This therefore implies that 3 minus a times -2 plus b times -2 squared minus -2 to the power 3 should be equal to what? 45. This should be equal to 45. So we can simplify. We'll have 3 plus 2a's plus 4b's plus 8 is equal to 45. This gives us the first equation. A plus 2b's is equal to 17 when we simplify. Now the second condition is 3 minus x is equal to 0, and which is a factor. So we have 3 minus x equals 0, implying that x is equal to 3. And since this is a factor, it means that f of 3 will be equal to 0 because this is a factor. So this will give us the same thing. We have 3 minus a into 3 plus b into 3 squared minus 3 to the power 3 is equal to 0. When we simplify the second one, we have 3 minus 3a's plus 9b's minus 27 to be equal to 0. And this gives us equation 2, which is minus a plus 3b equals 8. So we can solve these two equations directly by elimination. If we add equation 1 to equation 2, this will give us 5b's to be equal to 25, implying b is equal to 5. We now substitute the value of b in one of the equations, equation 1, b. So from equation 1, a will be equal to 17 minus 2b's. That is 17 minus 2 times 5. That is 17 minus 10, which is 7. Okay, so this is it for the first part of this question. And the second part is we should express 5x over x plus 3 into x minus 2 in partial fractions. Guys, please don't forget to subscribe to this channel. And if you need past papers, go to www.gcemathpanel.blogspot.com and equally subscribe so that whenever we have any new post, traveling abroad for studies, different concours in the country, have to prepare for exams, and different subjects, you can always get the notifications. And this can only happen if you subscribe. Without subscribing, you can't watch paper 3. So let's express this in partial fractions. We know that is the simple case. So this will be identical to, with this denominator, we have linear factors, right? So we just have a constant over the first linear factor plus another constant over the second linear factor. Now we multiply all through by this denominator of the left-hand side. We'll be left on the left-hand side with 5x is equal to a over x plus 3 times this LCM. Will be left a into x minus 2. When we multiply b as well, we'll be left with b into x plus 3. So we can use the cover-up method, right? So what will happen if x is equal to 2? So we are taking this first factor here and equating to 0. X minus 2 equals 0, so x is equal to 2. So if x equals 2, we substitute in this equation that we have, this 5x equals that. We will have 5 times 2, which is 10, is equal to a into 2 minus 2. This part will become 0, so we have covered up this part, plus b into x plus 2, but that x is 2. So we have 2 plus 3, which is 5 times b, 5 b's. That gives us 10 is equal to 5 b's, and b equals 2. Now we use the other factor x plus 3, equates to 0, and solve for x. We'll have x equals minus 3. So what will happen when x is equal to minus 3? When x equals minus 3 and we substitute in this equation, we'll have minus 3 times 5 is minus 15 is equal to minus 3 minus 2 is minus 5 times a minus 5a's. And this other part, we have covered up this part because it disappears. This is some sort of elimination, which they call cover up. So that now that we have our values of a and b, our f of x becomes 3 over x plus 3 plus 2 over x minus 2. So we have expressed this in partial fractions. We have expressed it in partial fractions. And all of this question is 8 marks. That is 5 plus 3, 8 marks. Don't forget to subscribe. Now the second question reads for June, and if you look at June 2021 very well, it is almost exactly the same as June 2019. The questions have slightly changed. So this is exactly June 2019, which has been moderated or modified and put here. You can visit our channel on YouTube, GCE Math Panel on YouTube. You will see 2019, the questions and the answers. You see 2020, the questions and the answers. And now 2021, you equally see other years, they're like 2016, 2013. And if there are other years you want us to solve, then you should get to us on the links. Leave a comment here that you would like to see this particular year or this year. And then we are going to upload it. Some of these corrections are not on YouTube. So it is good you visit our blog, www.gcemathpanel.blogspot.com, where you can find the corrections we have hidden there. So this is question 2. It reads, given that the roots of the quadratic equation x squared plus 2k plus 2 into x plus 2k plus 5 equals 0 are alpha and beta, A, find the values of the constant k for which alpha equals beta. So the roots are alpha and beta. And the first case, we want us to find the values of the constant k for which alpha is equal to beta. And B, if k is greater than 0, normally it means that from the A part, we may have the values of k which are positive and k which are negative. So in this B part, we are going to use the value of k that is positive. So B reads, for k greater than 0, that is strictly greater than, find the quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. And the second part of the equation is to find the range of this inequality. Let's start with the first part. So we have been told that the roots of this quadratic are alpha and beta. We should find the values of the constant k for which alpha equals beta. So normally the general form of the quadratic is x squared minus sum of root plus product. So this quadratic here should be identical to x squared minus sum of root, which is alpha plus beta, plus product, which is alpha beta. And from this point, our alpha plus beta, that sum of root, should be equal to minus 2k plus 2. Can you see? So we equate the coefficients of x on both sides. You see that alpha plus beta is equal to minus into 2k plus 2, right? Then this 2k plus 5, which is a constant on the left-hand side, the corresponding constant on the right-hand side is alpha beta. So our alpha beta is 2k plus 5. 2k plus 5. Okay, now if alpha is equal to beta, what happens? If alpha is equal to beta, then for the first equation, we will have 2 alpha because alpha is equal to beta. So we'll have alpha plus alpha, which is 2 alpha will be equal to minus into 2k plus 2. And for this second equation, what are we going to have? You will have alpha, so we can replace this value of alpha in this second equation here, right? Since our alpha, because when we simplify this one, we'll have alpha is equal to minus into k plus 1 because 2 is common. So if you substitute this value of alpha in this second equation, that is alpha beta is equal to 2k plus 5, then we will have alpha is minus into k plus 1, right? So we have minus into k plus 1 times minus into k plus 1 should be equal to 2k plus 5. So alpha is equal to beta here. We have minus into k plus 1 times minus into k plus 1 is equal to 2k plus 5. When we expand, we'll have k squared plus 2k plus 1 on the left-hand side should be equal to 2k plus 5 on the right-hand side. When we bring like terms together, these two k's are common, right? So we'll have k squared to be equal to 4, and our k will be equal to plus 2 or minus 2. So those are the two values of k for which alpha is equal to beta. K equals 2 or k equals minus 2. Now they want us to find the quadratic equation with whose coefficients or roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. And here they want us to use the value of k that is positive in this same equation above. So let us move with this. So for k greater than 0, it means that the value of k is 2, right? So we are going to substitute k equals 2 in this given equation. And this will give us x squared plus 6x plus 9 equals 0. So from here now, we have alpha plus beta in this equation is minus 6 because this is x squared minus sum of roots plus products. So alpha plus beta is minus 6 and our alpha beta is equal to 9. Now let us look for the new sum because they want us to use 2 alpha plus alpha beta and 2 beta plus alpha beta. So what's our new sum? Our new sum will be equal to 2 alpha plus alpha beta plus 2 beta plus alpha beta. And this will give us 2 into alpha plus beta. That's 2 alpha plus 2 beta, 2 into alpha plus beta, plus 2 alpha beta. But we know that alpha plus beta is minus 6 and alpha beta is 9. So this will give us 2 into minus 6 plus 2 into 9. When we simplify this, we are going to have minus 6 as our new sum. So our new sum is minus 6. Now our new product will be 2 alpha plus alpha beta times 2 beta plus alpha beta. When you open, you have 4 alpha beta. That's 2 alpha times 2 beta will give us 4 alpha beta plus 2 alpha times alpha beta will give us plus 2 alpha squared beta. Now alpha beta times 2 beta will give us plus 2 alpha beta squared, and alpha beta times alpha beta will give us alpha beta all squared. So with this one at the center, we can bring like terms together and do some modification. So for 4 alpha beta plus 2 alpha beta into here, we'll have alpha, and with this one we'll have beta. And then we continue with our alpha beta all squared. Now we know the values of alpha beta and alpha plus beta, so we just substitute those values here and simplify. All right, so this is what we have, dear candidates. This is what we have. So therefore means that our new product is equal to 9. When you simplify all of this, you'll have 9. And therefore our new equation will be given by x squared minus sum of roots plus product, which is going to be equal to x squared minus sum of roots, that is minus 6x plus 9 equals 0. A lot of students had a problem with this question at the GCE when they were marking. So it is possible that this type of question may come again next year. Or if it does not come next year, they'll give it the year after next. Like the questions of 2019 had a lot of problems. They have given most of them again this year. The GCE does not really change. You just have to answer as many past questions as you can and also study in class. You cannot answer those past questions without content mastery. Okay? And solve as much as possible. Even as you watch this video and you don't understand something, rewind it and watch again. And as you watch, solve. Make sure that you solve everything that has been solved here. You can use other methods. It must not be exactly the same method here. Hope you understand this. Very important. Now, to find the range of values for which this makes sense, there are two methods. We are going to use the two. So we can use the method of how can we put it? So we have this. So for this particular inequality, we know that the denominator should not be equal to 0. If it's equal to 0, this will be undefined. In this case, therefore means that our x cannot be equal to -1. Because if x equals to -1, this inequality will be infinity, which will make it undefined. But x can be equal to 2. If x equals to 2, this value will be equal to 0. This thing will be defined. So the boundary solutions are, we have -1, which is not inclusive, so we are not going to shade it. And we have 2, which is inclusive, which is included. So here, this is a number line. -1, it cannot be equal to -1, so we have not shaded it. But you can have 2. This is equal to 2, this inequality will be defined. So this here, we are going to use less than or equal to if it exists. And here, we should not use the equal to sign, whether with less than or with greater than. So these are the different regions that we have. These are the boundary solutions. So we can test each of the regions. Not that inequalities, we are looking at a range of values, not a particular value. That's why we're using this. So we can test, let's start with the region below -1. The region below -1, take any number less than -1. For example, -2 and test. So 2 minus -2, the numerator is positive. The denominator, -2 plus 1 is negative. So the numerator is positive, the denominator is negative. Positive divided by negative is negative. Now question, is a negative number greater than 0? No. It means that this region below is the wrong region. Now let's test this region in between -1 and 2. Take any number between -1 and 2, for example, 0, and test here. We have 2 minus 0 is 0. So numerator is positive, but denominator 0 plus 1 is 1. Denominator is also positive. Positive divided by positive is positive. Is a positive number greater than or equal to 0? Yes. This means this middle region is the correct or the satisfying region. Take any number above 2 and also test. For example, 3. 2 minus 3 is negative with the numerator, and 3 plus 1 is 4, positive with the denominator. Negative divided by positive is negative. Is a negative number greater than or equal to 0? No. It means that the region above 2 is the wrong region. Therefore, our solution set is x is strictly greater than -1 and less than or equal to 2. Or you can write it in interval notation as from -1 to 2. Can you see? -1 is not included. That's why this thing is like this. Or you can use a normal bracket here. But for this one to the right, after 2 is included, so you cannot use that bracket, use this square bracket. Okay, so you can write in interval notation like this or with this other form. Now let's look at the other approach. We can use the table as well, right? So by table, we can use the table approach. So by table is just the same thing, okay? You can use any of them. So by table, from these boundary solutions, we have this x. We have the region x is less than -1. We have the region x is less than is greater than -1 and less than or equal to 2. And you have the region x is strictly greater than 2. Now these are functions. The numerator is 2 minus x and the denominator is x plus 1. So this divided by this or this times this, whatever, is going to give us the function below here, f of x. F of x is equal to numerator divided by denominator, right? Now let's test the region. So it's the same thing. Any number less than -1, for example, -2. Fit -2 here, 2 minus -2. The sign is going to be positive here. This sign is positive. Then minus 2. You fit minus 2 here. This one is going to be negative. And what is positive divided by negative is negative, right? So f of s is negative. Now let's take any number between minus 1 and 2. 0, for example. 0, for example, and fit here. 2 minus 0 is 2, which is positive. 0 plus 1 is 1, which is positive. And positive divided by positive is positive. Now take a number greater than 2, for example, 3. 2 minus 3 is negative. 3 plus 1 is positive, and negative divided by positive is negative. Now we are looking for the region that is greater than or equal to 0. The question says greater than or equal to 0. So we are looking for the region that is positive because they say greater than or equal to 0. If they said less than or equal to 0, we will take the negative one, right? So this one is the one that satisfies that inequality. So our solution set is x is strictly greater than -1 and less than or equal to 2. So this is it for question 2. And make sure if you are watching this question, make sure you watch this paper to the end. There is no need to watch this paper, just half of this paper. You can equally get a lot of materials by going to www.gcemathspanel.blogspot.com, and you can visit that page every day for our updates. Some of you like specos. We don't believe in speco, but we have specos on that page. And all our specos, you can see the testimonies on that page for yourself. Question 3, show that 3a minus sine a over cos 3a plus cos a is equal to tan 2a. Guys, with this question, please do not try to expand this thing and simplify. You will suffer and you might never get to tan 2a. Yes, it will become very difficult for you and you might not find yourself at tan 2a. Let us look at the first part of this question, then we move to the second part of it. So with this question, this is what we are going to have. So we know that we have to work with the left-hand side and show that the left-hand side is equal to the right-hand side. So we have sine 3a minus sine a over cos 3a plus cos a. This will be equal to, now this is the hint. We will have to move from sum to product property for numerator and for denominator. We know that sine a minus sine b is equal to 2 cos a plus b on 2 sine a minus b on 2. This is the transformation from sum, from difference to product. This is the transformation. So here, according to this question, our a here is 3a and our b is a. So this will be written as, and for the denominator, cos a plus b or cos c plus d is the same as 2 cos c plus d on 2 cos c minus d on 2. You know these transformations. If you use this transformation, you get your answer in a few steps. If you try to expand, it will take a very long time and you'll just be suffering yourself for nothing. So the shortcut and the fastest way here is to use this transformation, okay? So the numerator is going to give us 2 cos 3a plus a on 2 sine 3a minus a on 2 over the denominator we'll have 2 cos 3a plus a on 2 cos 3a minus a on 2. So this will be equal to 2 cos 2a sine a on 2 cos 2a cos a. Okay? But now this cos 2a cos a will cancel out with the 2 and we'll be left with sine a on cos a. And you actually even see that with this question, this is equal to tan a and not tan 2a. So you have to emphasize in your response that this is not equal to that. When they start to show that something is equal to this, doesn't mean that it must necessarily be equal to that thing. Well, we think that this must have been a typing error. So when you solve, don't worry. The markers know exactly how they're going to take care of this problem, okay? Yeah, they know exactly how they're going to take care of this issue. So you don't have to bother yourself about anything. You don't have to worry yourself. So it does not mean that all the time they start showing that this is equal to this, means that it's equal to that. You have to prove at times and you start it is not equal to. The B part of the equation states that given that f of theta is equal to sine theta minus root 3 cos theta, express f of theta in the form r sine theta minus lambda, where r is a positive constant and lambda is an acute angle. So we know that r sine theta minus lambda, when you expand, we are going to have r into sine theta cos lambda minus sine lambda cos theta, right? And this is identical to what we have in the equation. In the equation, we have sine theta minus root 3 cos theta. So sine theta minus root 3 cos theta. So from here, we see that if you equate the corresponding components, what do you see? You see that r cos lambda is equal to 1. R cos lambda is equal to 1. And look at this other part. This minus, this is a minus here. So we have r sine. This is it, cos theta, we cancel with cos theta, right? So we have minus r sine lambda is equal to root 3. Okay. Minus r sine lambda is equal to minus root 3. So the minuses will cancel out. And we are left with r sine lambda is equal to root 3. So from here, we can look for r, right? We know that r, if you square both sides and add them, so we have the left-hand side, r cos lambda squared plus r sine lambda squared should be equal to 1 squared plus root 3 squared. And the left-hand side, when you square the left-hand side, you have r squared into sine squared lambda plus cos squared lambda is equal to, on the right-hand side, 4. Note that root 3 squared is 3 plus 1, 4. But sine squared lambda plus cos squared lambda is 1. Therefore, r squared is equal to 4. And r is equal to 2 because the equation says that r is a positive constant. We can now look for the acute angle lambda. So r sine lambda divided by r cos lambda, we can divide. We will have tan lambda to be equal to root 3. And from here, lambda will be equal to arc tan root 3. And arc tan root 3 is pi on 3. If you use a calculator with a cos, with a angle in degrees, you have 60 degrees. You can convert to radians, okay? So you have pi on 3, that's the value of lambda, right? Now they want us to find, so this f of theta can be expressed as r sine, according to the equation, theta minus pi on 3. They want us to find the general solution of the equation sine theta minus root 3 cos theta equals root 2. Since they have said hence means we must continue with this last answer we have. We have no other choice. We must continue with this answer. You have no choice. There's no other method you use. That's the hence. If you use another method, that's advanced level. Don't follow instructions, you are in the pit. So we continue with this. We know that this sine theta minus root 3 cos theta is equal to what we have here, which is 2 sine theta minus pi on 3. And so we can replace it by that value. So sine theta minus pi on 3, please, this is theta, not 3. Okay, let me just adjust it. Okay. All right, theta. So minus that, so we have sine theta minus pi on 3 is equal to root 2 on 2. And root 2 on 2 is sine pi on 4, sine pi on 4, right? 45 degrees. So how do you solve the equation sine A equals sine B? For sine A equals sine B, we will have the general solution, theta minus pi on 3 is equal to n pi plus minus 1 to the power n times pi on 4. And our theta now will be equal to n pi plus minus 1 to the power n pi on 4 plus pi on 3, where n is an element of the set of integers z. So this is our general solution for this given question, okay? So take a good look at it. And as I said at the end of this question, or as you are watching, be solving. Don't just watch this paper. This is not a movie. This is not an Indian movie or a Hollywood movie. You don't have to kill yourself. It's not Bollywood, Nollywood, or Hollywood. Maybe it's even Kamwood. Don't waste yourself and disturb yourself here. There's no Kamwood. Okay. So this is the shortcut for sine A equals sine B. This is what you use to solve when you have sine A equals sine B. Question 4. The real value function f is defined by, so this function is a real value function. So it's defined by, we have 4x on x minus 1, where x is an element of the set of real numbers. And x should not be equal to 1 because the function will be undefined, right? Show that f is injective Then find f of x, stating its domain. This is exactly 2019 question that I've just modified a bit. The same thing. Let's answer the A part and then we move to the first part and then move to the second part, okay? So a function is injective if what happens? Function is injective if f of x is equal to f of y implies x is equal to y. So f is injective if f of x equals f of y implies x equals y. For every x and y, an element of the set of real numbers. So f of x here, f of equals f of y will be implying 4x over x minus 1 is equal to 4y over y minus 1. You cross multiply, you have 4x into y minus 1 should be equal to 4y's into x minus 1. We expand, we have 4xy minus 4x to be equal to 4xy minus 4y's. So 4xy we can cancel out on both sides, and when we subtract them, we are left minus 4x equals minus 4y's and x equals y. So therefore, f is injective. F is injective. Now find the function, the composite function f of x and state its domain. So you are going to replace x in this function by f of x. So we have f of x will be equal to 4 f of x over f of x minus 1. This will be equal to 4 into 4x over x minus 1 over 4x over x minus 1 minus 1. We simplify that, we will have the numerator 16x over x minus 1. The denominator, we will have 4, that is 4 over x minus 1 minus x minus 1 over x minus 1, right? So we bring those terms together, this is what we have. And here the denominators are common, so we can just cancel out. We have 16x over 3x plus 1. And this function, they say you should state the domain. Don't bother to solve, they say state, they can still solve, no problem. So this function is defined if this denominator is not equal to 0. So if 3x plus 1 is not equal to 0, and you solve for x not equal to minus 1 on 3, so that's the domain. If you look at the question they gave before, this is the same thing, right? So you can also add x an element of R, and x is not equal to minus 1 on 3. That's the domain of the function. The B part is on logic. So we have this logic. Two statements P and Q are given by P, the principal goes to the ministry, and Q, the principal will meet the minister. Write out the following proposition in ordinary English. This is P and Q, right? So the principal goes to the ministry and will meet the minister. That's the first one, right? That's the and statement. The principal will go to the ministry and meet the minister. I can equally write it like that. That's English. Then the second part is negation of P or negation of Q. You have to be careful with this one. I've made a truth table here to explain it. So we have P and Q. This is P, this is Q. Negation of P, negation of Q. So the negation of P or negation of Q is the same as the negation of P and Q. So this one is just equals the negation of this first statement, because this first statement is P or P and Q, right? So this second one is the negation of this first statement. So we write it as, and the negation of P and Q is written as not P or not Q, right? And but this statement is the negation of P or Q. So the negation of P or Q is not P and not Q. So we are using the second one, okay? So we have, you can use either two. So the principal does not go to the ministry or will not meet the minister, okay? The principal does not go to the ministry or will not meet the minister. But the negation of P or Q, P and Q, okay, this is it here, as we have just mentioned. So that's what we have, okay? All right, so the negation of P implies negation of Q. Equally, the truth table tells us that this is what we have, the truth table. Negation of P implies negation of Q. So if the principal does not go to the ministry, then he will not meet the minister. So the principal does not go to the ministry. The principal does not meet the minister. So if he does not go, he will not meet the minister. Okay. Question 5, the equations of two lines are given by R equals that is I plus AJ minus K plus lambda into I plus 2J plus 2K, and R2 is AI plus 2K plus mu into minus J plus 3K, where mu and lambda are scalar parameters. Given that R1 and R2 intersect, find the value of the constant A. Is just 2019 again. The position vector of the point of intersection, and the cosine of the acute angle between R1 and R2. So this is on vectors. And if you go to GCE Math panel, we have some questions like this on vectors. Please go to GCE Math panel classes online. You will see most of these notes which we have to students. The notes are available in video form and in PDF. So you can go through the notes. If you don't understand something, you watch the video. Those are the lessons. And on GCE Math panel classes online, visit that page. We have further maths, we have chemistry, physics, biology. We have all of those subjects there. Just go there. Though the site is there, many students are not visiting it. If you don't know how to get there, just type www.gcemathpanel.blogspot.com and you click on the take me to that link. It will take you there. Don't forget to click on the subscribe there so that whenever you upload notes or videos or speco or whatever you call it, you can actually have access to them. And you can follow us on Facebook because we also do broadcasting every Sundays. You send your questions, we answer them and broadcast them on Sundays, or on Mondays. You can equally send your questions, but visit www.gcemathpanel.blogspot.com. You have all this information there. So the equations of two lines are given by that and that. Find the value of the constant A. So since they intersect, means that line 1 is equal to line 2. So we equate the lines, right? So we can write them in column matrix form. R1 will be 1, the coefficients, right? So we have 1 plus A minus 1. So we have 1 plus A minus 1. Then plus lambda times 1, 2, 2, right? So plus lambda times into 1, 2, 2. Then this should be equal to the line 2, which is A2. That's A. The y component is not there, right? So the y component is 0. So we have the jth component. So we have A02. Then plus mu into, with this mu also the I component is not there. So we have 0 minus 1, 3. So we equate these two, right? When we open out, we have the equations. For the I component, we have 1 plus lambda is equal to A. That's equation 1. Then for the jth component, we have A plus 2 lambda is equal to minus mu, equation 2. And for equation 3, we have minus 1 plus 2 lambda is equal to 2 plus 3 mu, equation 3. So we can solve these three unknowns. But since this question wants us to find A, we can just look for A directly, right? So in equation 1, we make lambda the subject, and lambda will be equal to A minus 1. We substitute in equation 2. We will have A plus 2 into A minus 1 is equal to minus mu. When we simplify this, we'll have 3A's minus 2 equals minus mu. So here we have made mu the subject. So mu the subject becomes 2 minus 3A's. As we have made mu the subject, now we substitute in equation 3. This will give us minus 1 plus 2. Our lambda, original lambda is A minus 1. And then plus 2 into 3 mu, which is that. We simplify all of this. When we simplify this, we are going to have 11A's to be equal to 11. And A is equal to 1. 11A equals 11 and A is equal to 1. From here, the values of these other parameters, now know that lambda should be equal to A minus 1. So 1 minus 1, which is 0. And mu, what is mu? Mu is equal to 2 minus 3A. So it's just 2 minus 3, which is minus 1. Now, the B part of the equation wants us to find the position vector at the point of intersection. For this position vector, we can just substitute the values of A and mu into the equation that requires a and mu, or the ones with a and lambda. So this will give us for the position vector, which is R0. We can use the first equation. We will have 1, 1 minus 1, because a is 1, right? Plus lambda. The lambda value at the point of intersection is 0, right? All right, so this gives us 1, 1 minus 1, because lambda is equal to 0. Then we can equally use the second one. You can use R2. You still have the same result as you can see. We have our a is 1, so we have 1, 0, 2 plus our mu is minus 1 into 0 minus 1, 3, right? So minus 1 here, 15 minus 1 here, and simplifying. We have 1, 1 minus 1 as well. And this is because mu is equal to minus 1. Now find the cosine of the acute angle between R1 and R2. For the cosine of this acute angle, we need to find the magnitude or modulus of each of the direction vectors. Note that when you're finding the cosine of the acute angle, you use the direction vectors. Like here for the vector R1, the direction vector is 1, that is I plus 2j plus 2k. And the second vector, the direction vector is minus j plus 3k. That is what we are using to find the cosine of the acute angle, okay? So we have to look for their magnitude. So for the first one, the magnitude of I plus 2j plus 2k is 1 squared plus 2 squared plus 2 squared, which is the square root of 9, which is equal to 3. And for minus j plus 3k, the magnitude is, or the modulus is root 10. So we have 0 squared plus minus 1 squared plus 3 squared, that is equal to root 10. And then we now look for the dot product of these two direction vectors. So we have 1, 2, 2 dots, 0 minus 1, 3. So this will give us 0 times 1 plus 2 times minus 1 plus 2 times 3. So that gives us a value of 4. And how do we get the cosine of this angle? Cos theta is equal to a dot b, where this a is the first direction vector, b is the second direction vector, a dot b over mark a mark b. A dot b is equal to 4 over mark a mark b is 3 root 10. So this is the direction of the cosine of the acute angle, right? This is the cosine of that acute angle between these two vectors. Guys, don't forget to subscribe. If you don't subscribe, there will be no way for you to watch paper 2. And equally, you can visit our page every day at www.gcemathpanel.blogspot.com, where you have past papers and answers. You can equally follow us on Facebook, where we post all of our announcements, our links, our lessons, our PDF, everything, SPECOs, and so on, and other groups of the GCE. And our channel on YouTube is www.gcemathpanel. I'm sorry, it is GCE Math Panel on YouTube. There you can find everything that we have done. For some of the videos or lessons which you have hidden, you can find them on our GCE Math Panel online classes, or you still go to www.gcemathpanel.blogspot.com. Economics, geography, history, chemistry, physics, all of that. You get all of the stuff there, okay? Stay tuned. Question 6. Evaluate the integral from 0 to pi on 3 of cos 3x to the power 4 sine 3x dx. Note that cos to the power 4 of 3x is the same as cos 3x, all that to the power 4. B, find the volume of the solid generated when the curve y equals x cubed is rotated completely about the x-axis between the ordinates x equals 0 and x equals 3. All right, so let's evaluate this integral first. So we can if you look at this integral, if you differentiate cos 3x, you have minus 3 sine 3x, right? So we can let our u be equal to cos 3x. So let u be equal to cos 3x, and du will be equal to negative 3 sine 3x dx. We can now copy out Or we can now solve for sine 3x dx because we see it in this integral. This is sine 3x dx. So we can make sine 3x dx the subject, and sine 3x dx will be equal to minus 1 on 3 du. Now we equally know that cos 3x, all of that to the power 4 will be equal to u to the power 4. So this integral will give us, of course, 3x to the power 4 sine 3x dx will be equal to the integral of u to the power 4, this u to the power 4. And sine 3x dx, as we already know, is minus 1 over 3 du. So this gives us a du times minus 1 over 3. You can you can put the minus 1 over 3 outside the integral sign, okay? So we integrate this now. We will have minus 1 over 3 u to the power 5 on 5 plus a constant. I'm not going to put a constant because this is definite integration. So this integral now will be minus 1 on 15 cos 3x to the power 5 from 0 to pi on 3. When you integrate this, what we are going to have. These are the limits of integration. So when you integrate that, that's what you are going to have. Now, upper limit minus lower limit, you have minus 1 on 15 into 3 times pi on 3 is pi. Because pi is minus 1. Minus 1 to the power 5 is minus 1, right? And then we have 0, because 0 is 1. So this gives us minus 1 minus 1. And this integral is 2 on 15. The integral here is 2 on 15. Yes, it's always very simple. When the teacher has done it, the teacher always does a simple example. Even when the teacher does the most difficult ones, students will see that the teacher did the most easy one or the easiest one. Now let us find the solute of this figure generated when this curve y equals x cubed is rotated completely about the x-axis between the ordinates x equals 0 and x equals 3. So this volume is defined as the integral from a to b of pi y squared dx. This is the integral we are looking for the volume of solute of revolution about the x-axis. Our a here is equal to 0 and our b is equal to 3. Our y is x to the power 3, right? So this will give us the integral from 0 to 3 of pi x to the power 3 all squared dx. So this is the integral of pi, the integral from 0 to 3 of x to the power 6 dx. So this will be equal to pi into x to the power 7 on 7 from 0 to 3. And this will give us pi on 7 into 3 to the power 7 is 2187 minus 0 to the power 7 is 0. So this gives us 2187 pi on 7. So that's the volume of the solid, and we have this volume in cubic units. The volume of the solid of revolution about the x-axis from x equals 0 to x equals 3 of the curve y equals x cubed. That's the solid, the volume of the solid of revolution. Okay. Let's move to question 7. Show that the equation f of x equals 0, where f of x equals 3x cubed minus x squared plus 3x minus 1 has a root between 0 and 1. If you have an issue with this lesson, you can go to our GCE Math Panel online on YouTube. This particular lesson is found in advanced level polynomials. You have answered this in polynomials. The lessons on polynomials, how about 4 lessons on polynomials? We have answered this day. And we show how a function has a root between a value of a and a value of b, right? The second part of the equation reads, given that the parametric equation of a curve are sine 2 theta for x and y equals cos 2 theta, find the squared y on the squared x in terms of the parameter theta, And sub 3, show that the function f is such that R is mapped onto R, the set of real numbers, where f of x equals 2x plus 5 to the power 3 plus x is an increasing function. Let's see how we answer these questions, beginning with the show that the equation that has a root between the 0 and 1. So a function has a root between 0 and 1 if f of 0 times f of 1 is equal to or is less than 0, is negative or less than 0. So we have to look for f of 0. Our f of 0 here will be equal to 3 into 0 to the power 3 minus 0 squared plus 3 into 0 minus 1. And what does that give us? Minus 1, right? Now, what is f of 1? F of 1 will be equal to 3 into 1 cubed minus 1 squared plus 3 into 1 minus 1. And that gives us 4. Now, f of 0 times f of 1 will be equal to minus 1 times 4, which is minus 4. And this minus 4 is less than 0. This minus 4 is less than 0. Therefore, we conclude that f has a root in the interval 0 to 1, or between 0 and 1. Then sub 2. Given that the parametric equations of a curve are x equals sine 2 theta and y equals cos 2 theta, find the squared y over dx squared in terms of the parameter theta. So this is parametric differentiation. We are going to answer this question in two ways. Can answer this question in two ways. The first one is working with parametric differentiation for second derivative. We know that dy dx is the same as dy d theta on dx d theta, or you can write dy d theta times d theta dx. This is the same thing. And if you have to have d squared y over dx squared, this will be equal to d theta of, that is d theta, look at it very well, d theta of dy dx, that is it, all that on dx d theta, all that on dx d theta. That is how you have the theta here. Look at this is theta and this is theta. But this one here is dy dx matching with this d squared y dx squared. So we can use this formula, right? So let's use this one first. The first method. So this is it here. So dx d theta here will be equal to, when you differentiate sine 2 theta, you have 2 cos 2 theta. So dx d theta will be 2 cos 2 theta. And when you differentiate cos 2 theta, you have minus 2 sine 2 theta. Okay? Minus 2 sine 2 theta. Now let us look for dy dx. Our dy dx will be equal to, because according to this formula, you now need dy dx before you can differentiate this one, right? So I need this dy dx to now differentiate it. So dy dx will be equal to dy d theta on dx d theta. That gives us minus 2 sine 2 theta on 2 cos 2 theta, which is equal to minus sine 2 theta on cos 2 theta. You can write tan 2 theta, right? But I don't want to write it because I want to use the quotient rule. I want to leave it like this so I can use the quotient rule here. Now, what will be d squared y over dx squared? It will be d theta of this our dy dx here. So this will be equal to, so we start by looking for d theta of dy dx, right? So this gives us bottom constant for this one, that is cos 2 theta. We differentiate the top, we have minus 2 cos 2 theta, right? Now minus the top constant, that is minus sine 2 theta. Now minus the top constant. We differentiate the bottom. When you differentiate the bottom, we are going to have minus 2. Oh yeah, bottom constant differentiate the top, minus the top constant now, minus, so we have 2 minuses here. Minus the top constant will differentiate the bottom. You have 2 minuses. This minus is inside here. Differentiate the bottom. All this on the bottom squared. So you have cos 2 theta all squared. So this gives us minus 2 into cos 2 theta squared, this is it now, cos 2 theta plus sine 2 theta all squared. This is the minus you have factorized because minus times minus times minus is minus. So we factor it out. And this will give us that. But we know that cos squared 2 theta plus cos squared plus sine squared 2 theta is equal to 1. So this gives us minus 2 over cos 2 theta all squared, or cos squared 2 theta, as can write it. So what will be our d squared y on the x squared now? It will just be equal to this value divided by the x d theta, or the x d theta is 2 cos 2 theta. So this will be equal to minus 2 on cos 2 theta all squared divided by the x d theta divided by 2 cos 2 theta. And that will give us minus 1 on cos 2 theta to the power 3. Cos 2 theta to the power 3. So this is the value that we have for this first method. Let us look for another method that we can do the same thing. So alternatively, we know that we can convert this. This is like the equation of a circle with radius 1. We know that x is equal to sine 2 theta and y is equal to cos 2 theta. If we square both sides, we will see that x squared plus y squared is equal to 1, right? Yeah, because sine squared theta plus cos squared theta is equal to 1. So therefore, x squared plus y squared will be equal to 1. Then we now differentiate, implicit differentiation. We differentiate 2x with respect to x, x squared with respect to x, we have 2x dx, plus differentiating y squared with respect to y, we'll have 2y dy, and we differentiate 1, we'll have 0. So we simplify this, we'll have dy dx will be equal to minus x on y. So now for second derivative, you can differentiate this dy dx, right? So the squared y over the x squared will now be equal to, keep the bottom constant y. You differentiate the top, you have minus 1. Now minus the top constant, so minus x constant, differentiate the bottom. Be careful here, this function is a function of x and y in terms of x and y. So when you differentiate this y here, you have dy dx. All this on the bottom squared, all that on y squared. Okay. Yeah, some of you like to say the buttock squared, but please, not buttock squared. That's what students taught me in class, but I'm not using that. I don't know, they always hear some type of things instead. So this gives us minus y plus x. We can now replace this y x here by minus x on y, right? That's what we have here. All that on y squared. And this will give us minus, we simplify numerator, we'll have minus y squared plus x squared on y, all that on the denominator. So this can be further simplified to give us minus 1 on y for the numerator, because we know that x squared plus y squared is equal to 1. From this first line here, x squared plus y squared is equal to 1. So we can replace this with 1. We have minus 1 on y squared, and this gives us minus 1 on y cubed. But it's not any here because we have been told to give our answer in terms of the parameter theta. So I'm going to replace y cubed by, I'm going to replace y in this equation by the y value in terms of theta. So this gives us minus 1 over cos 2 theta to the power 3, or cos cubed 2 theta. Cos cubed 2 theta. So this is another method. So you can choose one of them and you use the one that you think you can easily work with. You choose that one and work with it, okay? Don't forget to subscribe before you watch paper 3, because without subscribing, you'll not be able to watch paper 3. And when you subscribe, also click on the notifications. Notifications will notify you immediately the lesson is uploaded or the video is made available immediately. So you have to make sure you subscribe and share this video and leave your comments. Let us know what you think. Leave your comments. Share your likes and dislikes. Tell us what you think about the video. Tell us the issues you have found out with. It's very important. Otherwise, we might not know where we are all moving to. We should not be making sense. Now, the last part of the question says that we should show that this function, where R is mapped onto R, is strictly an increasing function. A function is strictly increasing if its gradient is always positive. That is, if the derivative of the function is always positive, right? So if the gradient function is always positive, we have to look for dy dx, and that will give us, you bring down the power 3, differentiate the core, differentiate this core 2x minus 5, you have 2. Now times the function itself and subtract 1 from the power. So times 2x minus 5 to the power 2. And when you differentiate x, you have 1, right? Now when you look at this function, this 2x minus 5 is always positive. 3 is positive, 2 is positive. So all of this function is always greater than 0. So this function is always, in fact, the smallest value that this function can take is when this is equal to 0, and that smallest value is 1. So this function is always positive. Therefore, f is strictly an increasing function. So f is strictly increasing. All right, question 8. The sum of the first and second terms of a geometric progression is minus 5, while the sum of the fourth and fifth terms of the same progression is 40. Find the first term and the common ratio of the progression. The B part, find the term independent of x in this expansion. Yes, this question was one of the toughest questions that disturb students during the GCE. And this type of questions have the tendency of repeating. If you look at 2019, you see a similar question like this, the A part of this question. And many students had a lot of issues here, a lot of issues. We are going to give you a shortcut and an easier way to answer this type of question. So you have been told that the sum of the first two terms is minus 5. You know the first term is a, second term is a plus, that's the second term is AR. So we have our a plus AR to be equal to 5. And we have been told that the sum of the fourth and fifth terms of the same progression is 40. The fourth term is AR to the power 3, as you know, right? And the fifth term is AR to the power 4, and this is equal to 40. So for each of these two equations, we factorize such that we have 1 plus r in both. Like the first one, equation 1, we factorize this, we have a into 1 plus r because a is common. And the second one, you see that AR to the power 3 is common. So we have AR to the power 3 into 1 plus R. And at this point, it's very easy to divide both equations and solve for R directly. So we now say equation 2 divided by equation 1 will give us. So when you divide, you have 40 divided by 5 is 8. This 1 plus R will cancel out 1 plus R. A will cancel out with A, will be left with R to the power 3. And so therefore our R is equal to 2, as easy as ABC. All the other methods will only give you stress. Avoid them. Use this short straight method, okay? Okay, so this is the common ratio of the progression. Now, how do we get the first term? You just substitute this in any of the equation, like in equation 1. We will have, since our R is 2, we will have a plus 2a, which is 3a is equal to 5, and a is equal to 5 on 3. This equation that students will spend about 15 minutes just to answer this part, and they will end up not having the answer. Look at how short and simple it has been. Use this approach for this type of questions, okay? Now the B part said, and look at it, 6 marks. Find the term independent of x here. The general term is given by CR plus 1 is equal to n combination R, a to the power n minus R, b to the power R. Now for the term independent of x, we are going to have 15 combination R. Our a here, this first part of this is x, right? So we are using as our a. So we have x 15 minus the power 15 minus R. And our b here is 2 over x squared. So we have 2 over x squared to the power R. So this is what we have. We simplify it. We have x to the power 15 minus R times, this is 2. You can write this x to the 1 over x to the power 2 all raised to the power R as x to the power minus 2r. Can you see? So you can write that it's 2x to the power minus 2r. The terms with x to the power something is of our interest. So the general term will be given by this 15 combination r, 2 to the power minus 2r, x to the power 15 minus r minus 2r. So this gives us x to the power 15. Now, if the term independent of x, this x to the power whatever will be equal to x to the power 0. So this is our focus. The term independent of x, this 15 minus r minus 2r should be equal to 0 because the term is independent of x. So we have 15 to be equal to 3r, because I have 15 minus r minus 2r equals 0. So 15 is equal to 3r and r is equal to 5. So this will be the term independent of x. Therefore, that term independent of x is the sixth term actually. So our t will be equal to, that term will be equal to 15 combination 5. You now put in the formula times 2 to the power minus 10 times 2 to the power minus 10. We are not using this x to the power whatever because all of this is equal to 1, right? X to the power 0, which is 1. So this term independent of x will be equal to 15 combination 5 times 2 to the power 2 into 5. That's 2 into minus 2 into 5. And this gives us 3003 on 1024. So that is the term independent of x. Question 9. Given the complex numbers z1 equals 4 minus 5i and z2 equals p plus 4i, where p is an element of R, find the value of p for which z1, z2 bar is purely imaginary, where z2 bar is complex conjugate of z2. Hence, find the absolute value of z1 and the argument of z2 squared. The B part, given that z is equal to x plus iy, where x, y are elements of the set of real numbers, find the locus of the point z such that max z equals z minus 2 plus 2i. Yes, this question also troubled a lot of students, and we have been receiving a lot of messages from WhatsApp and from the link in www.gcemathfinder.blogspot.com asking us to answer these questions. Students have been sending this question so many times. So students equally had a lot of difficulty with this question in the exam. But this question is quite easy. It's quite easy. So given this complex number z1 and z2, to find the value of p for which this z1, z2 bar is purely imaginary. So the complex number to be purely imaginary or purely imaginary, what does that mean? If it is purely imaginary, it means that the real part is 0, because the complex number is an imaginary one. It's just imaginary. Therefore means that the real part is 0. That is the idea we use to answer this part. So here we have z1, z2 bar. Note that our z2 bar here should be p minus 4i, because it says z2 bar, the complex conjugate. So that will be equal to 4 minus 5i times p minus 4i. Okay. So when we expand this, we will have 4p's minus 16. That's 4p's minus 16i's minus 5p's minus 20. Okay, let me look at this one again. So we have 4p minus 16i minus 5pi minus 20. So if we bring the like terms together, so we have 4p minus 20 minus I into 16 plus 5p. So if this complex number is purely imaginary, it means that this real part is equal to 0. Since it's purely imaginary, it means the real part equals 0. So we have 4p minus 20 to be equal to 0, and our p is equal to 5. Our p is equal to 5. Hence, find the absolute value of z1, that's the modulus, right? So max Z1 will be equal to, we have 4 squared plus minus 5 squared, the square root of that. That will give us the square root of 41. That is 16 plus 25, which is the square root of 41. Then find arc Z2 squared. So for arc Z2 squared, we can first of all decide to look for Z2 times Z2, which will give us a Z2 squared, and then you look for the argument. Or we can decide to use the formula that arc Z to the power n is equal to n arc Z. So we can look for arc Z for this one, arc Z, which is you have 5 plus 4i, right? So the argument of this complex number will be equal to 2 times arc tan 4 on 5, y component of x component. That will give us 2 into 0.675 radians, which is 1.35 radians approximately. So that is the argument of this complex number. Don't forget to subscribe and share this video. You can visit us on www.gcemathspanel.blogspot.com, where you get past papers, corrections, speculations, preparations, and all sorts of preparations for GCE are there. We have Black June, we have examiners bad hand, we have physics, chemistry, biology, maths. We have all stuff. You can visit us on Facebook and our live videos. We have advanced level classes mostly on Friday, on Saturdays, Sundays, and Mondays online. You can check that from our website or on GCE Maths Panel classes online. Let's answer the second part of this question, which states that given that Z equals x plus iy, where x and y are elements of the set of real numbers, find the locus of the point Z such that max Z is equal to max Z minus 2 plus 2i. So let us do this one. So we actually apply what we have here. We have been told that Z is equal to x plus iy. So we have Mac. The modulus of x plus iy should be equal to the modulus of x plus iy minus 2 plus 2i. On the right-hand side, we will have x minus 2, that's the real part, plus the imaginary part, I into y plus 2. Now the modulus for the left-hand side, I have x squared plus y squared square root, but there will be no need for us to put square root because we take the square root on both sides, we still have to cancel it out. So we have x squared plus y squared should be equal to x minus 2 squared plus y plus 2 all squared. We open out these brackets and simplify. We have x squared plus minus 4x plus 4 plus y squared plus 4y plus 4. And these terms will cancel out x squared on both sides as well as y squared. We are left with minus 4x plus 4y plus 8 equals 0. We bring like terms together. And this gives us an equation of a line. When we simplify, we have y is equal to x minus 2. So this is an equation of a line with gradients, positive 1, which is the equation of x, and the y-intercept is minus 2. So the locus of this point, Z, is a line with gradient 1 and intercept minus 2. That is it for question 9. We can now look at the last question. Have you subscribed? Before we look at the last question, if you have not, click on the link below this video and subscribe. With question 10, there are multiple approaches to answer this question. We have just looked at one. Find the value of the constant k for which the matrix A is singular. So a matrix is singular if the determinant is equal to 0, right? B, find the inverse of this matrix B, hence solve the system of equations. Find the image of the point minus 2, 3, 1 under the transformation matrix defined. So question 10a, let's see how we get to this question. Question 10a. So a matrix is singular if the determinant is equal to 0. We can use other methods to get this determinant. Let me use this method. Here, the determinant will be given by So you write out this matrix, then you copy out the first and second columns again. So you copy out 2, 1, 5, this is it. 3 minus 1, 0. Then now we get the product of each of the diagonal lines. So 2 times minus 1 times k, that gives us minus 2k. 3 times 2 times 5 gives us plus 30. 4 times 1 times 0 gives us 0. So the sum of all of this now minus, you now take the off diagonals from bottom left. You have 5 times minus 1 times 4. That gives us a minus 20 plus 0 times 2 times 2, 0, plus k times 1 times 3, which is 3k's. So this is going to give us the determinant of the matrix, right? So this determinant should be equal to 0 because they said the matrix is singular, right? So this is going to give us minus 2k's plus 30 plus 2k minus 3k equals 0. From there, 50 will be equal to 5k's, and we will have our k to be equal to 10. Another method is this second one. We can use this one, so we can use the minus and cofactors, the cofactors rather. So we have a 2 so, we have minus 1, 2, 0k. Then the next position is 3, which is going to be minus 3 into, you suppress this row and column. So we have 1, 2, 5k. The last one is 4, which is positive. You suppress this row and column where 4 is found. You have 1 minus 1, 5, 0. If you have issues on this, please watch the videos on matrices. It is written further math, but it's not further math, it is math. On this same channel, further math, you have determinant of 3 by 3 matrices. This is well explained there, all of these methods. It is written further math, but it is actually a math video. So since it's equal to 0, this determinant will give us the same value, and k will also be equal to 10. So we open this, we have 2 into minus 1 times k minus this. So we have 2 into minus k, which is minus 2k. Minus 3 into 1 times k is k minus 2 times 5, which is 10. So we have minus 3 into k minus 10. That will give us minus 3k plus 30. Then plus 4 into 1 times 0 is 0, minus 5. It's 5 times 4, 20. That should be equal to 0. So we have the same result, the two methods. Now we have to find the inverse of that matrix. We need to look for the inverse of the matrix. This is the matrix above here. To find the inverse of this matrix, be very careful. Though your k here is equal to 10, this is a different equation now. According to this question now, our k is 2. That's the value we are going to be using. Because if the matrix is singular, then we cannot look for the inverse. Therefore means that the B part will have no answer. Yes, a singular matrix has no inverse. Because when the determinant is 0, there's no inverse. So our k here, according to this question, is equal to what? It's equal to 2. So now we can look for the determinant. We already have this line here. We can copy this line and use. We already have the determinant. Our determinant will be equal to minus 2k. We can replace the k by 2 because the k here was something, it was k. Or we can use this same approach again to get the determinant. So this will be equal to minus 2 into 2 plus 30 plus 20 minus 3 into 2. The determinant gives us 40. 40 for the determinant. Then we have to now look for the adjoint of the matrix, because to have the inverse, we need the adjugate or the adjoint and the determinant. So the adjoint B star is given by the transpose matrix of cofactors. So we are going to come to this matrix that we have and get the cofactors. Like we use the this is the method of cofactors here. We get the cofactors. So the first cofactor is going to be a positive factor. So we have plus. The cofactor here is, first cofactor is obtained by suppressing the rows and columns. Suppress this row and column where this matrix is found. So we have minus 1, 2, 0, 2, because our k is 2. Minus 1, 2, 0, 2. The next cofactor, this position should be negative. The signs alternate. So we suppress this row and column. We have 1, 2, 5, 2. The next cofactor is here at 4. It's now positive. We suppress the row and column. We have 1 minus 1, 5, 0. If you don't like this method, you can use Cramer's rule to find the inverse of a matrix directly. You can equally get this video, or you visit GCE math panel classes online. You will see Cramer's rule to find the inverse of a matrix is very easy also. Though this one is a bit more difficult. The Cramer's rule is very easy. The next cofactor should be negative. At this position, we suppress this row and column. So we are going to have 3, 4, 0, 2. Note that our k is 2 in this case. So we have 3, 4, 0, 2. Next cofactor is positive. We suppress the row and column. We are going to have 2, 4, 5, 2. Next cofactor is here. It is going to be negative. We suppress this row and column. We'll have 2, 3, 5, 0. The next cofactor is here. It's going to be positive. We suppress the row and column. We will have 3, 4, minus 1, 2. Next cofactor is at this position. We suppress the row and column. We will have 2, 4, 1, 2. And the last cofactor is here. It's going to be positive. We suppress that row and column. We have 2, 3, 1, minus 1. So we look for all of these determinants. Minus 1 times 2 minus 0 times that. So we look for all of this and transpose. Don't forget the transpose. So when we do this, we are going to have the transpose of 2, 8, 5, 6, minus 16. This one here, we have 2 times 0, 0, minus 15, minus 15 is plus 15. Then we have 3 times 2, 6. 6 minus 4, 10. Here we have minus into 2 times 2, 4, minus 4. This is 0. This position, we have 2 times minus 1 is minus 2, minus 3, minus 5. When we transpose this, we are going to have the adjoint of this matrix. That's going to give us, we interchange rows for columns. So we have minus 2, 8, 5 becomes a column now. So, or we say minus 2, minus 6, 10 becomes a row. Minus 2, minus 6, 10. 8, minus 16, 0. 5, 15, minus 5. So that's the adjugate, right? From here, we can now have the inverse of this matrix. The inverse of this matrix, the inverse now be given by 1 over the determinant times this adjugate. So that's the adjugate that we had, and that's the determinant. So the inverse of the matrix is equal to 1 over the determinant times the adjugate. That's the inverse of that matrix. Now we can find the image of B. Can find the image of B, but there is a system of equations that we also need to solve. Okay. So normally this is the inverse of this matrix, right? Okay. Now let's solve that equation that's been given. Hence, solve the system of equations this. If you look at the coefficients of the x, y, and z in this matrix, you see that it is the matrix B, right? So that's matrix B times x, y, z. So we write it in this form, should be equal to the matrix on the right-hand side, 1, 2, 5. So this is the matrix B, this is the matrix X, and this is the constant matrix. From matrix properties, we can solve x, y, and z by using this procedure. Let us take analysis. So we have B times x is equal to C. If we pre-multiply both sides by B inverse, we are going to have B inverse times BX is equal to B inverse times C. But B times B inverse is going to give us the identity matrix here. And the identity matrix times X leaves X the same. So that's going to give us X to be equal to B inverse times C. It therefore means that to solve for X, Y, and Z, we just need to pre-multiply this constant matrix by the inverse of B. So that's what we're going to be doing. X, Y, Z will be equal to, that is the inverse, B inverse, right? Times that constant matrix there. And when we do this multiplication, we are going to have 9 on 10, minus 3 on 5, and 1 on 4. So those are the values of X, Y, and Z. You can do it and you have these values. Okay. The last thing is to find the image of this point. The image of this point is just obtained by pre-multiplying this point by the inverse matrix. All right, I'm sorry, by pre-multiplying this point by the matrix B. So to find the image of this point, so as you said, the image of this point can be given by pre-multiplying this point by the matrix B. So this will give us 2, 3, 4, 1 minus 1, 2, 5, 0, 2 times minus 2, 3, 1. And this will be equal to the matrix with points 9 minus 3 minus 8. So that's the image of the point defined by the matrix B. That's the image of that point defined by the matrix B. Thank you guys so much, and don't forget to subscribe and also watch paper 3. We have a lot more for you. If you need a personal tutor and you are financially able, I repeat, and you are financially ready, then you can get to us. If you're not financially ready, please don't get to us. Please, we are begging you, don't. So you can get to us through this number on screen on WhatsApp only on WhatsApp. Visit our blog on www.gcemathpanel.blogspot.com, and don't forget to subscribe. We thank you so much, and we beg you to leave your comments, to share this video as much as possible to all WhatsApp groups or Facebook groups, all groups to which you belong, and leave your comments as your friends to subscribe, so you continue to motivate our team, because the more they see students using the videos, the more they are motivated to work. We thank you so much, and we wish you the best. Don't forget to join our online preparation classes, and you can get to us using the WhatsApp number or visiting our blog, or get to GCE Math Panel classes online. Thank you so much. Don't forget to watch paper 3.